Alright, which of the following statements must be true whenever n, a, b, and c are positive integers such that n is less than a, c is greater than a, and b is greater than c? And then they've got all this messy stuff down here to look at. My suggestion with a question like this is let's go ahead and just try to get all of our information in order so that we can see what we're working with together. It can get very confusing with all of the inequality signs and all the different letters and trying to wrap your head around exactly what you're looking at. So let's simplify this process. Let's just make 4 blanks. And from smallest to largest, we're going to attempt to put n, a, b, and c in order. So I know that n is less than a. So I know that wherever a is going to be, n is going to be less than that. So I'll start right here and I'll move them if I need to. N is less than a, so n is smaller than a. Now I know that c is greater than a, so that's the next step. So we took care of this one. The next one is c is greater than a. So if this is a, c is greater than that, so it's going to be bigger. So I'm going to put it up here. And then the last one says that b is greater than c. So if b is bigger than c, then it's got to go past even c. Now I started, I guess, in the wrong place. So I'm going to scoot all this over so I can put b after c. So NAC, NAC is what we already had in the order, and then b is bigger than c, so b has to be here. So just based on what we know that if a is bigger than n, and c is bigger than a, and b is bigger than c, then b has to be obviously bigger than all of them, and n, vice versa, is going to be smaller than all of them. So by putting them in order from smallest to largest, it can kind of eliminate the need to have all of those inequalities, and it gets really hard to tell when you're looking at that, so this makes it just simpler. Now let's go ahead and look at the choices, and it says which of the following must be true. Not could be, but must be. That's a difference. So does a have to be smaller than n? No, actually it's the exact opposite. A has to be bigger than n, so that is not going to work. Okay, b. b minus n is bigger than or greater than a minus n. Now, if b is getting n taken away and a is getting n taken away, then that doesn't matter, because whatever you take away from b, you're also going to take away from a. So we know with algebra you can kind of basically say cancel those out or add n to both sides and it'll go away. So what we're really saying is, does b have to be bigger than a? Because subtracting n isn't going to change anything because it's on both sides. And we can see from here that b is the biggest, so obviously it'll be bigger than all of them, including a. So that must be true. So b is correct. Now just to clarify so you can see, let's look at the rest of these. Why would they then not have to be true? b is less than n. Well, that one's easy. b is the biggest one, n is the smallest one, so b is not going to be less than n. Okay, n plus b is equal to a plus c. Does that have to be true? So if you add the smallest one and the biggest one together, will it be equal to the two middle ones? I mean, yeah, I guess it could be. For example, what if n was 1, a was 2, c was 3, and b was 4? n plus b would be 5, and that's equal to a plus c, which is 5. Right? So it could be true, but what if b wasn't 4? What if b was 100? It's still in order. 1 is less than 2, which is less than 3, which is less than 100. And it doesn't tell us what a, b, and c, and n are. We just have to know what order they're in. So if this is the amount, then n plus b would be 101. And that does not equal to 2 plus 3. So yeah, it could be true, but we don't know what the numbers are specifically, so we don't know that it's true. So we can't say that d must be true. We could say it could be if they asked us, but it doesn't have to be. And then last one, 2n is greater than a plus b. So if you take the smallest number and you multiply it by 2, it has to be bigger than a plus b. And again, there's probably a situation where that's true. Let's say, what if n was 10, a was 11, c was 12, and b was 13? Now, well, no, even then it wouldn't be true. So you can see here, as far as must be true, well, it definitely doesn't have to be true, because 2 times n would be 2 times 10, which is 20, And is 20 greater than A plus B, which would be 11 plus 13, which is 24? No, that's incorrect. So obviously it doesn't have to be true, because we can think of at least one solution where that's not the case. B is the only one that has to be true.